All right, let's take on this problem 78 on page 295. It is a sister to problem 74. And, who picked this particular sister? Because, boy, it really wants to know a lot of information about this function f of x, this logarithmic function f of x. Find the domain, graph it, find the range, find any asymptotes. Do the same thing for the inverse of the function. So let's take it on. I think the best way to proceed is actually to graph it first, because you can then read the rest of the information off of that. And let's graph this by that method of using successive transformations that we've used in the past. In particular, let me just start by sketching in the natural log of x. The natural log of x goes through this point 1, 0, because after all, 0 is the exponent that you put on e in order to get 1. E to the 0 is equal to 1. So there it is, asymptotic to the y-axis. And we only do that because we then want to replace x with x plus 1. And you know that when you do that, you introduce a new vertical asymptote, because you shift the graph. All it does by replacing x with x plus 1 is to shift the graph, translate it without changing any shape, 1 unit. And so the graph y is equal to the natural log of x plus 1 looks just like this. Awful hard to draw that freehand. There, I'll stop there. Y is equal to the natural log of x plus 1. Great. Next step, let's introduce natural log of minus natural log of x plus 1. That takes this function and just flips it around the x-axis. So when I do that, I'm going to just try to draw this same thing here like this. That's the natural log of, this is y is equal to minus the natural log of x plus 1. And the last thing that I need to do then is to multiply this function by 2. So let me, because this is getting pretty busy, let me introduce this guy down here. And what I'm going to draw on it now is minus 2 times that. So I'm going to draw this graph too high. I'm going to multiply each one of these values for every given x by a factor of 2. So the graph that I'm going to draw down here is going to come down here, crash through 0, and go like that. So I will just sort of try to do that. And we're going to call that y is equal to minus 2 natural log of x plus 1. And that'll work just fine, because now from this graph we can quickly see what the domain is. The domain is all x that are greater than minus 1. X can't be equal to minus 1, but it can be any value greater than minus 1. So we've taken care of that, we've taken care of that. You can read off the range of f. All values from minus infinity to infinity are represented. You can see the asymptotes. There's a vertical asymptote right there. It is the line x equals minus 1. And that's, we've now sort of done everything that we are asked to do with respect to f. I now need to calculate f to the minus 1. So one way to produce this function is to start with its graph, perhaps, draw the line y equals x, flip this function around it, and I will have generated the inverse to this y is equal to f of x. But maybe we should do that algebraically. And to do it algebraically, we take this equation and we compose f with its inverse. That is, every place I see an x, I replace it with an f to the minus 1. And if that stayed on the line, you can see I've got a new expression, which is the composition of f with f minus 1. And if indeed f minus 1 is the inverse of f, then f of f to the minus 1 will be equal to x. And so I'm a little concerned that I've just drawn off my page here. So let me just transpose that equation down here. And let's go ahead and solve that by dividing both sides by -2. I get minus x over 2 is equal to the natural log of f to the -1 plus 1. And now let me raise both sides up as exponents on e. And I do that because e is an inverse to the natural log, and therefore this expression in the next line is just equal to f to the -1 plus 1, meaning f to the -1 of x is e to the minus x over 2 minus 1. E to the minus x all over 2 minus 1. And so fairly quickly we can say, well, you know, these are very nice functional values. 1 is always good. The domain is minus infinity to infinity for f to the -1. And we are not surprised by that because we note that the range of f is also minus infinity to infinity. And making use of the fact that the domain and range of a function and its inverse just swap, I can go look at the domain of f, and I can kind of immediately say that the range of f to the -1 is going to be y greater than -1. And in fact, to do the last step here, and that is to graph f to the -1, the way I'm going to do that, frighteningly, is draw y equals x. I'm going to draw y is greater than, I'm going to draw y is equal to -1. And now I'm just going to flip this value around in such a manner that it's asymptotic here and just takes off here. Okay. So there is the reflection of f about the line y equals x. That's f to the -1. Sure enough, it has a this limit to its range that y is greater than -1, as we expected. And so I think we've done everything asked of ourselves here. Good.